Okay, here are some notes on position, velocity, and acceleration functions. And first of all, I'm going to talk about a position function and what it really is. But here's kind of an idea, or almost a definition. Suppose that S of t is a function of time that describes the position of a particle moving along a coordinate axis, say an s-axis. Okay, now I drew an example over here so you can kind of see. So this is a function. And in this case, the motion of a particle moving along the x-axis, so our particle's moving back and forth along the x-axis, is described by S of t. So this is a function, and S is the position. And you can see over here my units. This might be in feet, and this might be in seconds. So my function is moving along, and the units here are in feet, and the time is seconds. And we can see when we start, and this is time, when t is 0, I'm at 5, so my initial position, my beginning position is at 5, so I would start here at 5. Okay. And then in 2 seconds, we're going to move to 10. So after 2 seconds, my position is 10, so I move obviously to the right because I'm going from 5 to 10. So that's after 2 seconds. And then after 2 more seconds, we're back to 0, so now I'm moving back to the left. So I'm going to be starting here, stopping, I'm moving to the left. And I keep moving to the left till I get to -5. And that's at 6 seconds. So I wrote the times over here. And then I stop here. And I start moving. Here I'm at -5. Okay. And now I'm moving back towards 0. So this is -4, 3, 2, 1. So now I'm moving back towards 0. So after 8 seconds, I'm back at 0. And then after another 2 seconds, I'm all the way up to 15. And then I just keep going. So this is how the position function kind of describes the motion. This is your position. I wrote it every 2 seconds. So at 0 seconds, I'm at 5. At 2 seconds, I'm at 10. At 4 seconds, I'm back at 0. We actually mark this over here. Then after 6 seconds, we're at -5. Then we turn around, start coming back up. At 8 seconds, we're back to 0. And then at 10 seconds, we move a little faster, so we're at 15, and we keep going. So that's kind of describing the motion. So that's what the position function does, and that's kind of how it works. So it's good to have an idea of how these values are changing with respect to time. Okay? And you can see, get some ideas here, that I'm moving faster when it's steeper, so that's a slope, so we have a tie-in. And actually, if we take the slope of this, that's going to be feet per second, it's going to give me velocity. So let's give you some definitions first, and then we'll see some examples. So here's some definitions. The displacement of the object over the time interval from t to t plus delta t, and sometimes we say t, comma delta t, t plus delta t, excuse me. This displacement is called delta x, s, or the change in position. That's going to be my position at t plus delta t minus my position at t. So this is my initial time t, and this is my final time t plus delta t. This change over here between here is delta t. This is what happens during this change of time. So if I start here and I end up here, then the displacement is just this position minus that position. In other words, if this was happened to be 0, just and say this is 2, this is 8. Then if I start at 2 and I end up at 8, my displacement is 8 minus 2, which is 6. Now, that's not necessarily how far I travel. That's just my displacement. In other words, I might start at 2 and I might go to the left, go to the right, and come back. So at t plus delta t, whatever that time is, I could have moved left, right, and end up there. All we know is that the displacement is the difference from where we started to where we end up. Okay? So we might have traveled more. In other words, if you start in the morning, you go to school, you forgot something and you go back, well, your displacement is 0 because you're ending up where you started at. But that doesn't mean you didn't travel, so you have to be aware of that. Okay? Then we have the average velocity. That's the average rate of change of an object. And we know the average rate of change is just the slope of the secant line. So the average velocity of an object on t plus delta t. So we have 2 points here. And we call that average velocity. That's the displacement over the travel time, or the change in s over the change in t. Well, we have already got the delta s over here. S plus t plus delta t minus s of t. So that would be my displacement. And my travel time would be whatever delta t is. If we take t plus delta t minus t, we get delta t. And we'll see some examples of that shortly. That's the average velocity. Now remember, if we took the limit as delta x approaches 0 of our slope, dy dx, and the difference in the x's is approaching 0, the x values, we have 2 points, then that's the derivative dy dx. So from the same perspective, the limit as delta t approaches 0 of delta s over delta t is the derivative of the s with respect to t. And that's going to be our velocity. That's going to be feet per second. That's the slope. So let's take a look at this. And this is the definition of instantaneous velocity. The velocity, or instantaneous velocity, is the derivative of the position function s of t with respect to time t. At time t, the velocity is, and this is the velocity, which is the derivative of the position function, or the slope of the position function, which is the limit as delta t approaches 0 of s of t plus delta t minus s of t over delta t. And we've seen that definition before. So again, that makes sense. The instantaneous velocity is just the derivative or the slope of the position function. And again, if we look at our position function, if our units are in feet and our vertical units are in feet, then the vertical change would be in feet. Our horizontal units are in seconds, so the horizontal change would be in seconds. So if we take the slope, that's the change in position over the change in time. That'd be feet per second. Well, feet per second is velocity, just like miles per hour is velocity. So that makes sense. Okay. So that's the first part. We got a little bit more, so we'll get to that in just a moment.